8:50, and it is time for me to begin. First of all, here we go. Kids in here late. Every day, just come to the Canvas page. There's brief videos that you should watch. So how to take and submit the quiz. If you would kindly watch that so I don't have to explain everything quickly. I'll cover everything in these two videos. There's a particular email you need to respond to send me your quiz because I would have 104 emails in my inbox. That's not going to work. So please respond to this email. If you mess up and you send it as a separate email or you email it in Canvas, I will kindly let you know and forgive you, but please respond. So there'll be a new one for each quiz, and respond to that because it's just a whole lot easier to proceed. And then the second one is I forgot to put some labels on the X and Y intercepts. If you have a paper copy, you want to put those in, but those are in the videos. You always need to watch those every day, and I'm not going to keep them up, past this week, but you need to watch it. Okay, so we should try to do a practice quiz today. And I need to say this, that the spiral questions are going to be optional while we're virtual. So I'm not going to have time to get to those today, but I really encourage you to do them. And you're going to have to look at my videos if you need help. Maybe you can figure them out on your own. But I really encourage, that is, okay, sorry about that. That's just a video that was finishing from my previous class. Anyway, I really encourage you to do them because it's a short retake if you should mess it up. And it's worth, it should be 100%. Like as a separate quiz because it counts as a separate score. Okay, all right, so I'm not gonna have time to talk about those today, but I encourage you strongly to do them. All right, so I'm doing practice quiz 2. You also have 1 and 3 in the videos. I noticed some really strange behavior on YouTube the last couple of days, maybe a couple of weeks here and there, like it would just go out. I hope that doesn't happen. It's back, but there's been some really weird worldwide weird stuff going on. So hopefully that doesn't happen when you need to access things. All right, problem 1. What is this about? This is what this is about. You're going to go left to right at the top here, and you're going to put in the factor with the power. So x plus 3, x plus 1 squared, and then 2x plus 3 squared. This is not how I did it in the video solutions. So the power on these factors is the multiplicity. And so I'll just go left to right. So this is a power of 1, and then 2, and then 2. So the power on the factors is the multiplicity, the exponent, because I'm going to go fast through part of this quiz to get it in. So when I say we got a multiplicity of 3, that means somewhere there's an exponent of 3. Now the 0 is related to the factor in the sense of literally the relationship between, x-intercepts. That's what a 0 is, by the way. X-intercepts, abbreviate there. So if you have x as a factor, then 0 is the 0. If you have x minus 1 as a factor, then 1 is the 0. If you have x plus 3 as a factor, then -3, and -1, and -3/2. So if you can't figure it out, you set it equal to 0, and then that'll get it figured out. But it is the relationship between, whoops, a little bit off the screen there, between x-intercepts and the factors. And this is something in my class that we spent a whole great long while on. So I don't expect you to get the 0 from the factor wrong. Okay, that's something you should know. Problem 2. What's the leading coefficient? Now, you can take this into Wolfram Alpha and type the whole thing in. You are welcome to do that. And you'll notice when you do that, that negative 16x to the 9th, and then I'll plus, a whole lot of other stuff. But that first term would be negative 16x to the 9th. So what's the leading coefficient? Negative 16. You are welcome to do that. I think that's just as valid as anything, telling me that you know what to look for. However, you don't need to type it into Wolfram Alpha. All you need to do is think about these leading coefficients. So negative 4 times 1 squared times 1 to the first power times 1 squared times 2 squared. So there's a bunch of 1s in there. You're only doing negative 4 times 2 squared, which 2 squared is 4, negative 4 times 4. So you're just taking that coefficient of x and performing the power, because that's what's happening. If you express that whole thing out, that's what's going on to get the leading coefficient. Okay, problem 3. Standard form equation. So what you're going to do here is you're going to go to Wolfram Alpha, and I'm going to actually do that now. And bam, here it is. You're going to type this in, make sure you have the word expand there, and it will expand it out. And then you're going to take this and you're going to write it in the standard form. You need to really do this every time, because I think there's a lot of power in having both. And when you go to answer all the questions, it'll be simple. So you write the result right in there. Okay, so what next? The degree and leading coefficient. So the degree is 4 and the leading coefficient is 2. You look at the leading term. So what we have is an even positive, meaning that both of these are infinities, which you're getting from this guy here. Even positive takes us right there. Okay, so this is legal to refer to on your quiz. And then the y-intercept is 0 because that's the number added on the end over there. Now we're ready to do this table, and that is related to the factored form. So we have an x minus 3 squared, we have an x plus 2. So that's 0 and 1, 3 and 2, negative 2 and 1. Remember, the multiplicities are the powers. Then what do you do on the graph? You take the y-intercept with the zeros. The zeros are the x-intercepts. And then at 3, we're going to bounce. So it's going to bounce and come back up. And then the rest is going to be cutting through. Now this, if you actually look at it, I mean, it goes down quite a ways. Way down there. Then it comes back up. Goes way up here. And if you technically wanted to say, all right, I want to know exactly what those points are, you could trace them out. You know, when you go to the Metacalculator, it has that little point, which is really kind of cool. That's actually do that. Not that. So here's the Metacalculator. Here's it entered in. So like you can say, oh, that's like 1.225. So like that peak is like up to 25. And then you can say, all right, like this one down here is close to negative 33. So like you actually can figure out if you wanted to, but it's not necessary. But there's some people that I want to know exactly how high up and how low down. What I'm looking for is the bounce at 3. So when it's an even multiplicity, it bounces. And the only even multiplicity we're going to deal with is 2. When it's an odd multiplicity, it cuts through. We're going to deal with 1 and 3. So 3 means that it's going to get flat, and we're actually going to come upon one of those very quickly. All right, problem 4, I got 10 minutes. So what you should do is expand this out. I put a line through it because at the time I did this, I didn't use Wolfram Alpha to do it, but it's probably wise business to do it because it gives you the y-intercept, and you can see really nice that leading coefficient. So I didn't do it, but I'm going to just go through this. So the degree is 5, the leading coefficient is 1, so we have an odd positive. The y-intercept is 16. Okay, so you should expect all that to show up when you do expand it. So this is the results from combining the degree, the odd positive there. And then you have to take all of this. Notice the power of 3 there. That's interesting. Down here, so -2 and 3, 2 and 1. Remember, it's the powers, 1 and 1. How am I getting the 0 for those of you that may really struggle? You're just taking the factor equal to 0. That's it. All right, so up at 16 here, and then -2, 2, and 1. And at -2, we have a multiplicity of 3, so it's going to come in and it's going to get flat through here. That's going to come up to 16. It's going to cut through 1, so turn around, cut through 1, dip down, and then back up through 2. Very good turn there. And both of those are a multiplicity of 1. So they're just going to cut straight through on that. Again, you can type this in and look at it. My graph is pretty rough, but what I need to see right here is the graph getting flat. So this is all about, do you understand relative to our x-intercepts, how the graph behaves when it cuts through? That's really what this is about. And then tacking the end behaviors on with that. And then if you continue in your math, you'll put even more of this together with some other things to figure out, okay, how low does that go? All right, 7 minutes. I got 5 and 6 to do. I can do it here. On 5, something interesting happens. So you have to take this in to a polynomial roots finder, and which our one that we use is called the math portal. And so you go in and you type it in. X, you need to use a little guy like that. Minus 6x squared plus 12x minus 8. Find roots. And you see you get, under the result, 3 2's. So that means that when we do this, we have x minus 2 3 times, which I'm going to write that like that, though, y equals. So you can understand that it's the power. So that's how you get, when you have this, there's one of these on the quiz, you need to go into the math portal site to get the zeros. Okay, and those of you with graphing calculators, when we're in class, I show you how to use this app. It is the same thing. It's just that your degree, you have to switch to 3, the order, and then put 1, -6, 12, and -8 in. Anyway, the math portal site's a lot quicker. All right, so the degree is 3. The leading coefficient was 1, so this is an odd positive. Y-intercept is -8. Remember, that's the number added on the end. Left end and right end behavior. So you look up on the sheet, an odd positive, and those are your end behaviors. So x minus 2 to the 3rd, 2 and 3. so that when it cuts through at 2, I'm hitting at -8 down here, it's going to get flat cutting through at 2. So you have to show it getting flat. And that is all on that one. Well, I have a little time to spare, actually. Okay, problem 6, this will be your tier 3. So what you need to do here is take your x and y intercepts and fill everything in up here. So we have a 0 of -2, 1, and 3, and it looks like their multiplicities are all 1. So how do I know that? Because it just cuts through, it's not getting flat, and it's not bouncing back from the direction it came. So these are all multiplicity of 1. So that means this would be all of our factors. And so that is going to be what we transfer up here. Times x minus 1 times x minus 3. Then go into Wolfram Alpha and expand that out. And this is what you would get, minus 2x squared minus 5x plus 6. And now you're ready to put all this together, and it has to make sense with what you see on the graph. Everything has to make sense. So the degree is 3, the leading coefficient is 1, so we have an odd positive, meaning negative infinity, positive infinity. And as you look at the graph, it's going down towards negative infinity and then up towards positive. Since I have a little extra time, 3 minutes, I'll show you these real fast. The 0.25 lies on this. So this is x, this is y, that means y. So you're going to put in, it's a game of substitution. And you know everything but b. This is that. So a lot of the problems you're going to get for your spiral are like SAT style problems, but it has a little bit to do with what we've done. 5 in for y, 2 in for x. Solve it out. Okay, so this would be 12 plus 2b plus 15. Okay, add the 12 and the 15 together, that's 27. And then you just solve it out. Subtract 27 over, divide by 2, negative 11. Pretty straightforward. All right, problem 8. So if you think in terms of the FOIL process, it has to be 7 and 1. It has to do this. If, in this, it doesn't matter where the 7 and 1 go. There's no other way that you can break that apart. So what does m have to be? Well, when you do the FOIL process, plus 1x plus 1, so 8x has to be. Pretty simple. I think worth doing. Again, we're going to make them optional, and but I would strongly recommend trying them because it's good to have. It's like another quiz score at 100%. Okay, I'm going to end, and make sure you watch those videos. Take the quiz tomorrow and submit it to that one email. And as soon as I get them, as soon as I grade them. Okay, we will see all of you on Thursday.